as a question from College Matriculation Pahang 2023 set 1 for topic 1 method. So for the first question, it asks us about the definition of relative atomic mass. So we know that the relative atomic mass, the formula of relative atomic mass is mass of one atom of an element divided with 1/2 times mass of one atom of 12 carbon mu. So if you already remember this formula, we actually can use this formula to turn it into a sentence. So which is we can make it into a mass of one atom of an element compared to as a division compared to 1/12 mass of one atom of 12 carbon with the mass of 12 mu. Okay, so this is the definition of relative atomic mass. So if you a Roman 2, the question say the sample chlorine consists of two isotopes, which is 35 Cl and then 37 Cl. Plus the relative atomic mass of chlorine is 35.5. Okay, then nak kita determine the percentage of composition of each isotope, which is dia nak isotope for the percentage of isotope Cl 35 and juga 37 Cl. Okay. Okay, so now we can just assume 35 chlorine is X%. Boleh je nak buat, kalau nak buat 37 chlorine X% pun boleh je, sebab dia akan dapat jawapan sama. So 37 chlorine is 100 minus X%. Okay, so we will use the average atomic mass formula, which is K me divided with K. K is abundance and M me is the mass. Okay, bagi the abundance. So 35, we do the 35.5, which is 35.5 is the relative atomic mass of chlorine is 35.5. Okay, so and then here K can, okay, K as times 35 the mass of chlorine for first isotope, and then the plus with the second isotope, which is the K for 37, the second isotope is this 100 minus X times with 37 is the second isotope, and then divide with the total of K, which is X plus 100 minus X. Okay, so bila kita buat calculation nanti dia potong-potong jadilah 100 sahaja. Okay, so 100 ni bawa ke sini darab, kita dapat 3550, and then yang ni sama dengan 35X plus this one kita darab, kembangkan, dapat 3700 minus 37X, and then bawa ke sebelah, pindah-pindah, kita akan dapat X sama dengan 75%. After kita dapat X equals to 75%, kita ambil another one. X equals to 75% is for this one. So this one is actually for the percentage for isotope 35, and then yang the second isotope is second isotope tu kan kita buat, kita siup 100 tolak dengan X. So X tadi ada 75 kan, so masukkan je 100 tolak dengan 75, dapatlah 25%. So kita conclude balik 35 chlorine for this isotope equals to 75%, and then the percentage of isotope 37 equals to 25%. So this is the final answer. Okay. So for the next question, it stated that compound A consists of carbon, hydrogen, and also oxygen, and the complete combustion of 1.74 gram compound A, which is 1.74 gram tu adalah mass of compound A, produce 3.96 gram of carbon dioxide and 1.62 gram water, and the molar mass of compound A is 58 gmol. So the question asks us to determine the empirical formula of compound A. So firstly, the tip that I would like to share is gather all the information given from the question. So we got the mass of compound A is 1.74, and then mass of carbon dioxide is 3.69 gram, and mass of H2O is 1.62 gram, and molar mass of A is 58.0 gmol. Okay, so this is the information that we gathered. So from the information that we gathered, we can start to find the find the empirical formula. Okay, so firstly, after we gather the information, we have to determine the mass of hydrogen, carbon, and oxygen by using the information given. So firstly, we have to find the mass of hydrogen from water. Okay, so we have to molar mass. So to find the hydrogen mass from water is molar mass of hydrogen in the water. Okay, molar mass hydrogen adalah 1 kan. So how many, and then we have to times the 2, because here there is 2 hydrogen in water, and then we will divide with the total molar mass in the water, which is 2 plus 16. 16 is the oxygen molar mass, and then we will times 1.62. Kenapa times 1.62? Sebab 1.62 is the total mass of hydrogen. Is the total mass of water. So when we do the calculation, we will get the H equals to 0.18 gram. So the second, we will stick to the same, which is carbon dioxide. So we cari the carbon mass from the carbon dioxide. So the carbon here ada 1 je kan in the carbon dioxide. So molar mass of carbon only 12, and then divide with the total molar mass of carbon dioxide. So dekat sini ada salah sikit. Okay, so dekat sini saya ada salah sikit. Okay, so 12 divide with 12 plus 16 times 2 sebab 16 oxygen yang ada dua dekat sini bukan carbon. Okay, and then we will times with the mass of carbon dioxide, which is the mass of carbon dioxide is 3.96 gram. So when we do the calculation, we will get the 1.088 gram. Okay, and then kita kan terdapat mass of hydrogen and carbon. So kita kena cari the mass of oxygen sebab in the question it stated that compound A consists of carbon, hydrogen and also oxygen. So another one is oxygen. Tapi kita tahu kita tak ada mass of oxygen berapa. So kita akan buat matematik punya cara, which is mass of compound A equals to mass hydrogen plus with mass carbon and plus with mass oxygen. So mass compound A that stated before is 1.74 gram. So 1.74 gram equals to mass hydrogen that we got just now, yeah, 0.8 plus mass carbon dioxide, carbon 1.08 and plus with mass of oxygen yang kita cari sekarang. So mass of oxygen kita tolak-tolak, pindah-pindah tempat semua, we will get mass of oxygen is 0.48 gram. Okay, so lepas kita dapat semua punya mass, macam mass hydrogen, mass carbon and mass oxygen, barulah kita boleh buat this table, which is empirical formula table. So this table you guys tulis penuh je, yang ni semua ni kena tulis penuh. Also elements pun kena tulis. Okay, so mass of carbon yang tadi kita just salin je balik apa yang kita dapat tu, 1.08 gram untuk carbon, 0.18 untuk hydrogen and 0.48 untuk oxygen. Okay, so kita cari mole. Untuk cari mole, we have to find mole for carbon, hydrogen and oxygen. So there's like one tip macam mana saya hafal. Okay, jap, this is the formula. Okay, so to find the mole of carbon and hydrogen and oxygen, we can use the formula. We can use this formula. This is how I hafal the formula lah, guna the triangle concept. So kita tutup sebab kita nak we want to find the mole. We want to find mole of carbon, hydrogen and oxygen. So kita tutup mole. So kita tutup hydrogen. And then we have to find dalam formula tu kita kena masuk mass and molar mass. So the mass for carbon is 1.08 and then bahagi dengan molar mass, which is 12, and then we got 0.09. So macam oxygen pun sama, mass of hydrogen is 0.18 over 1, which is 1 is the molar mass of hydrogen, and we get 0.18 and mass of oxygen is 0.48 that we got just now, and then divide with the 16 is the molar mass of oxygen, and then we get 0.03. Okay, so here after we already defined the mole, we have to find the mole ratio. Mole ratio ni we need to use the smallest mole ratio among this element. So the smallest mole among this element is 0.03, which is from hydrogen. So we will divide the mole number of carbon with 0.03. Okay, so 0.09 yang daripada carbon divide with the smallest ratio. With the smallest ratio 0.03, and then we will get the answer is 3, which is carbon has 3 atom, and then 0.18 the mole hydrogen is divided with 0.03 the smallest ratio, and then hydrogen ada 6 atoms, and then 0.03 for oxygen divide with itself, dapatlah 1. Okay, so the empirical formula is is C3H6NO. Okay, because O only one, so kita tengok dekat sini ada satu O. Okay, gitu. So this is the answer for question 1B Roman 1. This is the answer for the question. Okay, for question number 1B Roman 2 is related with the 1B Roman 1. So I will just skip it. Oh, okay, this is the question. This is the full question. So the question Roman 2 is it asks us to determine the molecular formula of compound A. So just now we got the compound A is. So just now we got the empirical formula of compound A is C3H6O. Okay, so how to find the formula, the molecular formula of compound A is the empirical formula times with n here, times with n, and then equals with molar mass of compound A, and then okay, so kita just masukkan je the numbers. Okay, so 12 times 3, which is carbon, the molar mass of carbon times 3, because carbon has 3 atoms in C3H6O. So for hydrogen, the molar mass of hydrogen ada the molar mass of hydrogen is 1, and then times 6 sebabkan dia ada 6 atom, and then oxygen 16 sahaja. 16 is the molar mass of oxygen, and then dia just 16 sebabkan oxygen ada 1 sahaja, which is actually dia macam ni lah, dia 16 times 1. So equals to the molar mass of compound A. And then we will buat calculation semua. We got the total molar mass number is 58. And then equals to 58, the real molar mass. And then dapatlah n equals to 1. So when n equals to 1, which it means that the molecular, the empirical formula and molecular formula is still the same, which is C3H6NO. Dia maksudnya macam ni. 1. So it's still the same. It's still the same. The molecular formula of compound A is still the same with the empirical formula. So this is the answer for 1B. 1B Roman 2. Okay, so for the last question of B, which is Roman 3, it asks us to balance the equation. Balance the equation of for the combination of compound A. So macam kalau kita sebenarnya from the equation given, dia kata the complete combination compound A produce carbon dioxide and water, which is dia punya hasil adalah carbon dioxide, CO2 and H2O. Okay, and also another tip is combustion means reacts with oxygen. Okay, they reacts with oxygen, aka pembakaran. Okay, so the compound A C3H6O reacts with oxygen sebab dia combustion kan, and then menghasilkan CO2 and H2O. Okay, yang ni already sudah diseimbangkan. So dia okay, dia ada 2 oxygen, ada 2, and H2O ada 3. Okay, so this is the balance equation for combustion of compound A. Okay, so for question 1C, it stated that an impure solid sample of iron reacted with an excess of hydrochloric acid HCl from an aqueous solution of iron to chloride, which is FeCl2 and H2 gas. Assume that the impurities do not react with HCl. So it asks us to balance the equation for the reaction. Okay, just now dia kata iron is Fe reacted means plus, and excess with hydrochloric acid plus HCl menghasilkan two form. Dapat tak? Two form means menghasilkan the solution FeCl2 and here means plus H2. So this is the equation. Tapi belum balance lagi, so kita kena balancekan dulu. Oh sorry, ni the equation that we get from the equation. And then kita kena balancekan dulu. Kita dah balance. Okay, so kita tengok dekat sini. Tengok dekat sini. Fe. Okay, so I have my tips lah. During SPM, I always tengok yang mana ada macam benda nombor ni dulu, baru I akan seimbangkan dulu benda yang ada number kat belakang. So Cl2 ada 2. So Cl kat sini ada 1 je. So kita kena tambah lah 2. Okay, and then H2, H ada nombor kat sini ada 2. So kita tengok H kat sini ada dekat sini. So H dekat sini dah ada 2. So kiranya dah okey lah. Dah seimbang. So Fe dekat sini just fine. Maksudnya dekat sini dah seimbang. And also, okay, so this is the equation for the question given. And also ada juga another tips, which is my teacher dulu pernah ajar kalau macam dia tak ada bagi, macam tadi kan soalan tadi dia ada bagi ni terus apa tu, iron to chloride ni dia terus bagi formula dia. Tapi macam tu lah, kalau dia just stated dia iron to chloride, macam mana kita nak buat kalau lah kita hafal kan. So macam kita nak buat ni is kita tulis Fe kan, tadi kan dah letak Fe2, so Fe2 plus lepas tu Cl minus, and then kita silangkan sahaja, silangkan the charge. So dapat Fe Cl2, dan Fe ni jadi 1 sebab dia dekat sini ada minus 1. Okay, so this is the tips lah. So for the balance equation for the reaction is yang ni, ataupun boleh ambil yang bawah ni. Okay, that's all. Okay, for the last question, dia cakap when a 0.27 gram of the impure iron is reacted, maksudnya impure iron ni adalah Fe reacted with HCl, an amount of 8.54 times 10 kuasa negatif 3 gram of H2, maksudnya this one is mass of H2 is involved. So calculate the percentage of iron sample. So kalau my tips, I will suggest you guys to buat the to tulis the equation, the balance equation, and then kita ambil the information from here, kita gather it dekat sini, which is Fe tadi ada ni kan 0.274 gram dia punya mass, and then H2 ada 8.54 10 kuasa negatif 3 gram. So ni adalah the information yang kita ada. Okay, after that, lepas kita dah dapat information, kita boleh buat calculation. So I have one tips juga, which is it called as monica. Monica means mole, nisbah and calculation. So number one kita buat mole. So kita cari mole of H2. So kita cari mole of H2. Tadi kita dah dapat mole, kita dah dapat mass of H2 dalam equation dah bagi 8.54 dan 10 kuasa negatif 3. Ni. And then kita divide with the molar mass. Divide with the molar mass 1 darab 2 times 2 sebab apa? Sebab hidrogen ada 2 kali. Dia kata gas hidrogen, so ada H2. Bila gas hidrogen means that H ada 2 kali. Okay, so kita akan dapat 4.27 darab 10 negatif mol untuk H2. Okay, so bila kita dah dapat mol of H2, kita buat step seterusnya. After mol dah done, kita cari ni pula. Okay, so ni is ratio, dalam bahasa Melayu ni sebab. So okay, tadi dekat sini here's the tips lah. Macam mana kita nak tahu kita nak kena apa macam guna nisbah nak bandingkan apa dengan apa. Kita tengok dalam soalan tu dia bagi apa? Dia bagi mass of ferrum, mass of iron kan. And then dia juga bagi dia bagi mass of iron which is ferrum. And then dia bagi mass of hydrogen. Maksudnya dia bagi dua nilai ni saja. So kita akan comparekan dua nilai ini sahaja. Okay, so for the ratio kita akan comparekan antara dua nilai yang begitu saja. So which is 1 mol of ferrum. Simbol ni dia bukan macam SPM simbol nisbah, tapi ini kita guna simbol yang tu. This simbol, okay, which is reactive with 1 mol of ferrum, sebabkan kat sini ada satu, and then yang ni pun ada satu saja. So 1 mol of ferrum reacts with 1 mol of H2. So yang mol tadi H2 yang kita dapat ni, dia tarik kat sini. So 4.27 darab 10 kuasa negatif 3 mol of H2 akan menghasilkan 4.27 darab 10 kuasa negatif 3 mol of Fe. So this is the mol for Fe. So dia actually macam ni. Macam yang ni kan dia senang sebab dia just 1 1. So kalau 1 1 mesti ni pun sama kan. Tapi kalau contohlah dia bagi soalan macam ni. Okay, contohlah kalau macam tadi kan senang, dia bagi macam 1 lepas tu 1. So kalau 1 mesti dah sama kan. Dia akan jadi 4.2 juga lah kan. Tapi kalau macam dia bagi nilai yang macam ni, 2 lepas tu 3. So macam susah lah, dia tak seimbang. Dia bukan tak seimbang, dia macam tak macam satu tadi. So kalau 2, 3 macam ni, my tips is yang nilai yang kita dapat, contoh 3 mol of H2 ni adalah 4.27 darab 10 kuasa negatif 3 mol of H2 ni, just contoh saja, okay, tak real pun. So kita akan buat kita akan buat darab 4.27 darab 10 kuasa negatif 3 mol of H2 ni akan darab dengan 2 mol of Fe. And then bila dah darab, kita akan bahagikan pula dengan 3 mol of H2. So macam ni lah dia punya equation dia. So nanti kita akan dapat lah mol of Fe berapa bila 4.27 darab 10 kuasa negatif 3 mol of H2 react with E, macam tu. Okay, so tu just tips lah tadi tu. Okay, so kita dah mol, kita dah buat ni, dan kita tinggal nak buat calculation sebab kita sudah ada mol, kita dah ada kita dah buat mol dan kita dah buat ratio. So kita tinggal pergi step ketiga, itu calculation. So kita dah ada mol of ferrum ni berapa, and then kita boleh cari mass of ferrum that reacted berapa. So 4.57 darab 10 kuasa negatif 3 times with molar mass of Fe 55.9. Ni selalu akan diberi. Okay, bila buat calculation dapatlah 0.239 gram. Okay, also saya nak cakap, every time kita buat pengiraan, please tulis formula sebab formula ni boleh dapat markah. Okay, and then dia tadi minta soalan tanya percentage of iron sample. So percentage Fe, kita guna ni, percentage Fe equals to actual Fe divided with theoretical times 100. So tadi kita dapat yang kita kira tadi Monica tu, kita dapat mass of Fe is 0.239. So kalau macam tu 0.239 ni adalah the actual one, and then the theoretical one ni selalunya akan diberi. So the theoretical one ni the mass of theoretical Fe ni dia dah bagi kat atas ni, just 0.274 gram. Ni adalah the theoretical. So kita just masukkan dalam formula, nanti kita akan dapat 87.23%. Okay, so that's all. So this is the answer for the question lah yang ditanya, the percentage of Fe that reacted. Okay, so this is the final answer. Okay, so this is the last question and dah habis kita punya perbincangan. So okay, bye bye, jumpa lagi nanti.